Hey everyone, welcome to today's Explainer. We are diving into something absolutely wild today, one of the most awe-inspiring, literally earth-shattering phenomena on the planet: volcanoes. We're going to break down the exact mechanics of why these massive geological giants actually blow their top.
So just picture this. You're walking through a completely quiet forest, minding your own business, and then suddenly, boom! The ground starts shaking violently beneath your feet. Ash completely blacks out the sun, and glowing, molten rock shoots straight up into the air.
It really makes you wonder, right? I mean, what is actually causing that? Ancient cultures used to think there were literally giant fire monsters living deep inside the earth. But the truth? The truth is actually driven by some spectacular, highly volatile science happening right beneath our feet. So let's solve this mystery.
Section 1. What exactly is a volcano? Okay, the best way to think about a volcano is like a giant geological chimney. But instead of letting out wood smoke from a cozy fire, this massive opening in the Earth's surface is venting melted rock, what we call magma, from deep, deep underground. And it's not just magma, it's bringing up heavy plumes of ash, toxic gases, and literal flying rocks along with it.
And here's the crazy part. This isn't just some rare, isolated thing. Right now, there are over 1,500 active volcanoes scattered all over the globe. That's a massive number. It's a completely global phenomenon that is actively shaping the planet we live on.
Section 2. Inside the Earth. Let's go underground.
So, to understand this, we have to look at how our planet is built. It's made up of distinct layers. Imagine a giant peach, right? The very thin outer skin of that peach, that's the Earth's crust. Then you have the thick, fleshy, juicy part inside, that's the mantle. And right in the center, that hard pit, well, that's the Earth's core. Now deep down inside that middle layer, the mantle, things get pretty intense. We're talking extreme conditions. The heat is so intense that solid, literal rock actually melts into this thick, glowing ocean of magma. It reaches temperatures of over 1,000 degrees Celsius. That is about 1,800 degrees Fahrenheit. Way, way hotter than boiling water.
Section 3. Why do they erupt?
So here's the secret. Magma isn't just liquid rock. It's incredibly pressurized and it is absolutely packed with trapped gases. It's honestly the exact same mechanism as shaking up a bottle of fizzy soda. As more of that magma and gas collect down there, the pressure just builds and builds, and eventually all that pent-up pressure totally overpowers the heavy rock above it, forcing the whole mess upward until, whoosh, it violently blasts right through the surface. Now, you should know that not all eruptions are these crazy explosions. Some of them are what we call effusive. That's when the melted rock just kind of gently oozes out, like thick syrup running down the side of the mountain. But others, those explosive ones we talked about, they're the ones violently blasting hot gases, ash, and rocks literal kilometers into the sky. And knowing the difference between these behaviors is absolutely crucial for scientists who are trying to predict when they'll go off and, keep people safe.
Section 4. Magma versus lava.
Okay, I want to clear up a super common point of confusion. What's the difference between magma and lava? Well, the distinction is surprisingly simple. When that molten rock is safely trapped underground, we call it magma. But the very second it breaches the surface and flows out into the open air, boom, it gets a new name: lava. It is the exact same stuff, just renamed depending on whether it's inside or outside the Earth.
Section 5. How volcanoes actually help us.
So, I know we've talked a lot about their destructive power, but get this. Volcanoes are actually totally essential for life as we know it. I'm serious. For example, once volcanic ash settles, it creates some of the most incredibly rich farming soil on the planet. And when volcanic rock cools down in the ocean, it forms absolutely stunning islands. Plus, we're even able to tap into their extreme heat to generate clean geothermal electricity for our homes. Oh, and right now as we're talking, deep underwater volcanoes are busy building brand new ocean floor. How cool is that? To really wrap your head around the sheer scale of these things, just consider Mauna Loa over in Hawaii. It is the largest volcano on Earth, and the tallest one. If you measure it all the way from its base, deep underwater, up to its peak, it literally dwarfs Mount Everest. Plus, these giants operate on massive geological timelines. A volcano can sleep completely quietly for centuries, literally hundreds of years, before suddenly waking up again.
Section 6. Time for a quick volcano quiz.
All right, let's see if you were paying attention to the terminology earlier. What is that melted rock called when it's still hidden safely underground? Is it A, lava,
or B, magma? Take a second and lock in your guess. If you went with B, magma, you nailed it. Remember, it's magma on the inside, and it only levels up to the name lava once it bursts out of the Earth's chimney.
Okay, question 2. What is the main thing that actually forces a volcano to erupt in the first place? Is it A, wind blowing across the top of the crater, or B, massive pressure building up from magma and gases?
Yep, the answer is B again. Just like that fizzy soda bottle we talked about, that trapped pressure just builds and builds until the magma has nowhere to go but up, and it violently forces its way out.
So today we've seen that these awesome natural wonders are really just the spectacular result of extreme heat, trapped gases, and unbelievable pressure deep down in the Earth's mantle. When we understand how this all works, we can really start to appreciate the insane forces that are constantly shaping our world. And remember, pretty much every great scientific discovery out there starts with just asking one simple word: why?
You've totally unlocked the mechanics behind volcanoes today. But, it kind of leaves you wondering, if there are giant glowing rivers of liquid rock creating all this immense pressure right under our feet right now, what other kind of explosive hidden science is going on deep beneath the ground just waiting for us to discover it? Well, keep asking those big questions, and I will see you in the next explainer.